Hey, this is Mr. Field. I'm going to give you an introduction to algebra tiles today. We're going to use these a lot throughout the year to help us represent different algebraic expressions and equations. These are really useful all the way up through late Algebra 1 as far as representing everything that we'll be doing from then on. And they'll really help most students get a good understanding of algebraic concepts that gave us adults so much trouble back in the day. Now what we have is three different algebra tiles. They're colored on one side and they're red on the other. They're each red on the other side to indicate negative numbers. We're going to start with the little yellow square. Now all of this is based on an area model. So if we look at the area of this square, we're going to agree that the length of this square is 1 unit long. And since it's a square, that means that the width of it is also 1 unit long. And we all remember from years ago that the area of a square is just like the area of a rectangle. It's length times width. In this case, we have a square with an area of 1. So from now on, we're going to use this little yellow square to represent 1. And as I said earlier, a red one will be negative 1. Okay? Now we're going to pull out the little green rectangle. Notice that it has the same width as the square. It is 1 unit wide. However, if we try to measure the length of it, we'll find that we really can't come up with a good answer for how long it is. It doesn't line up perfectly like that. And so what we find is we don't really know the length of this. And so we can imagine this green rectangle as sort of a magic box that contains an unknown number. Could be 1,000,000, could be 0, could be 3, we don't know. But we're going to call this length x, which is usually what we use in mathematics to represent an unknown number. So we have a rectangle here with an area of x times 1, length times width, and that is x. So from now on, this green rectangle is x. And, as you might have imagined, this, whatever x is the opposite of it. We call that negative x. So it doesn't matter if x is 1,000,000, this is negative 1,000,000. It doesn't matter if x is 3, this is negative 3. It doesn't matter if x is 0, this is 0 is its own opposite, so this is also 0. So whatever x is, this is going to represent the opposite of it. Okay? Now, we have another piece here that we won't use at all in 7th grade math. But if you'll notice, this square is x units long on one side and x units long on the other side. And x times x is x to the second power, or x squared. We also have negative x squared. We're not going to use either one of those in any of the upcoming videos. These come much later as we start factoring and multiplying with polynomials and binomials in algebra. Okay, so these are gone. Now, what we can use, and this is very useful for middle schoolers, what we have here is 1 plus negative 1. Now, we should have already learned in 6th grade and years before that any number plus its opposite is 0. We can look at this on a number line and see if we have negative 1 and we add 1, that means we go to the right 1 space, and 1 space to the right of negative 1 is 0. So let's all just agree for now that 1 plus negative 1 is 0, and we're going to call a little yellow and red pair like this from now on a 0 pair. And there are several ways to show 0. This is 0. It's just 2 plus negative 2. This is 0. This is 3 plus negative 3. And even with our x's, we can show zeros. Any number plus its opposite, these are 0 pairs. That's important for us later because anytime we add or subtract 0 from something, it stays the same. So that's the beginning of the algebra tiles and 0 pairs.